Hello my friends, this is Alexander Barmin and this is my new YouTube show LeetCode with me, where we solve LeetCode coding challenges. Don't forget to subscribe to my channel and give me a like and write a comment, obviously. So what's in the agenda for today? Today we will solve a coding challenges about linked list. So let's get started and go ahead. So let's start, and our today's coding challenge is about two numbers. You are given two non-empty linked lists representing two non-negative reverse order, and each of their nodes contain a single digit. Two numbers and return the same as a linked list. So from my perspective, a linked list is a very good data structure, but it almost never used anywhere else apart from coding challenges. So let's take a look into the coding challenges we're provided with. So this is our number 2, 4, 3, first number, second number 5, 6, 4, and we need to sum digit by digit. 2 plus 5 is 7, 4 plus 6 is 0, and 3 plus 4 plus 1 is 8. So this is roughly speaking the main complexities, because we're dealing with two challenges here. First of all, it is linked list, and secondly, we need to keep in mind that by summing number we can have values which are more than 9, so that we need to add value to the next digit as well. So let's write it down. So we have element A plus element B, and it has some value equal to C, and in case if C is less or equal to 9, that's fine. If C is more than 9, roughly speaking it's 10, 11, 12 and up to 18, we need to create a node with value, roughly speaking, 10 minus value, 10 minus sum, and we also need to memorize the rest. So that's it. This is the main complexity of this. As I said, this is the main complexity of this task. Apart from that, everything is relatively simple. And second part is that we're dealing with linked list. Linked list is very good for technical interviews, but it never used in real life, almost never used in real life. So that because this is a linked list, it has a reference to next element. So apart from reading in this order, we also need to write elements in this order. So this is what we're asked to do. We need to create a list node which will be ahead of a new list which contains sum of two elements, and we need to return it, right? Apart from that, we need to know which node we're dealing with currently, which node of the whole, roughly speaking, of the sum of the list with the sum. So because we have head and we need to return the head, and also to this head we will attach additional nodes from left to right. So this is first, this is second, this is third, fourth, and so on. But what we need to return is head node. So that we need to know which is our current node, which is also null by default. And apart from that, we need to store this rest somewhere. So this is should be a variable here, because it should be available across our iterations over these two linked lists. So the next part is relatively simple, but let's take a look. So we need to iterate both the lists simultaneously until they have next elements. And roughly speaking, we're not dealing with index in this linked list, we're dealing with node themselves, and every list node is roughly speaking, is a container which has a value and has a reference to the next node. So that's what we need to do. We need to check that we still have a first node, or we have second node, we have not iterated till the end of the list, or our rest is more than 0. Why it's important? So imagine the situation when we're summarizing two numbers like 4 and 8, and these two numbers are last one element in both the lists. So sum is 8 and 4 is 12. So in this case we have to write 2 to our current node, and also we need to write somewhere with 1. So that this is why we need to check that rest is still more than 0. So next step is to create a sum. We starting to summarize elements from different lists, from first list, from second list. So here what we're doing is we're checking if we still have element in the first list. So current element is in the first list is not null, so that we know what element we need to sum with. So we're summarizing with it, val, and we're moving pointer L1 to the next element of the first list. L1 is equal to L1 next. So what does it mean? So this is our L1, and currently it is pointing to 2. We're taking 2 and moving pointer to 4. In the next iteration we will move it to 3, and in the next iteration we will move it to null, so that this condition will not be true anymore. The same work for the second list. L2 is not equal to null, so that we're adding sum is obviously plus and equal L2 dot val. L2 is equal L2 next. So we're moving pointer in the second list to the next element in it. And next we should not forget about our rest, which is left from the previous iteration. So sum is equal plus equal to rest. So now the magic starts. So our rest should be calculated as we have sum, and we need, in case if sum is more than 10, it should be 1, otherwise it should be 0, right? And sum itself should be, if it is more than 10, we should take 10 minus sum, otherwise it is sum. This is interesting. This is first option how we can implement it, and actually we have a second way to implement it. We can use division, and we can take rest. So roughly speaking, we can say rest is sum divided by 10. So in case if value is more than 10, like it's 11, this value will be 1. And sum itself is sum rest of the division. So in case if sum is more than 10, this rest will be 1. And here, in case if it is more than 10, this sum will be a rest of division. So roughly speaking, this is the same as it is written here. But this approach will work even in the case if we're dealing not only with 10, but also, for example, with 12, 30, 40, and so on. So it's a bit more convenient way to write the same. And last one step. So imagine the situation when we just started to create our result list, and our head node is still null. So that we need to check if our head node is null, so that we need to create a head node. It's new list node which stores only sum, and our current node is head. Why it's important for us to have a pointer to the head and a pointer to the head and to the current node? So because we need to attach one element to another, and we need to return head as a result. So we also always should have a pointer to head, first of all, and secondly, we will attach new nodes to our current node. So this is the first iteration, and also we have a second iteration when first head node is already created. So in this case we need to create a new node, list node next, which will be new list node with value inside. And now we need to attach this next node to the current node. So current dot next is equal to next. So what does it mean? So we have current node, we created a new node, and we're saying that, well, this new node is attached to the current node as a next element. So this is what we're doing. This is the first line, and second line which we need to write is that, okay, newly created node will be our current node, so that in the next iteration when we'll create a new node, it will be attached to the current. So current is equal to next. And let's give it a try. Voila, it works, and let's submit our solution. Voila, it works quite well, by the way. It beats more than half of all Java implementations. It takes only 2 milliseconds to be performed, and by memory it beats also more than half. So that's it. That's it for today. Hope you enjoyed the video, and if so, please give me a like, subscribe to my channel, and write a comment. See you next week. Bye.